Hey there, GVR pre-calc students. Hope that you all are doing well. I wanted to go through a couple more examples with solving general trig equations in case you just want to see a little bit or a few more examples and get a bit better of an understanding of how to go through these types of problems. Alright, so let's get started. So the first problem we're going to look at, we're trying to find all solutions to the equation of 1/2 sine theta is equal to negative square root of 3 over 4. So we want to remember when we're starting these problems, first thing that we want to do is to get our trig function by itself on one side of the equation. So for this problem, we're going to multiply both sides of the equation by 2. That way that's going to cancel out this 1/2 and get sine theta by itself. So then when we combine these two expressions, we're going to get sine theta equals negative square root of 3 over 2. Okay, so now is when we want to think about our unit circle, and we're trying to think, when is sine theta equal to negative square root of 3 over 2? And we also want to remember that sine theta is our y value, so that's going to indicate that our angles are going to be in the third and fourth quadrant. So we're thinking about that, and you will remember that when sine theta is equal to negative square root of 3 over 2, that means that our angle is going to be either 4 pi over 3 or 5 pi over 3. So we know that those are the two angles that we're working with. Okay, going to move forward. So everything that we just did is over here on the left. So we know we're going to have those two equations, theta equals 4 pi over 3 and theta equals 5 pi over 3. But we want to remember that we're finding all solutions to the equation, not just those two. So we want to add our period to both of those expressions. And our period for a sine equation is 2 pi. So we're going to add 2 pi n to both of those angles, giving us theta equals 4 pi over 3 plus 2 pi n, and theta equals 5 pi over 3 plus 2 pi n. And that's our final answer for this equation. Cool. Going to have to go through another problem now that's a little bit more extensive. So we have square root of 3 over 3 is equal to cotangent of theta plus pi over 6. So again, the first thing that we want to be thinking about with a problem like this is getting our trig function by itself on one side of the equation. And we have that right now. We have our cotangent and its argument, theta plus pi over 6, by itself. So we don't need to worry about this pi over 6 for the moment, but now we're ready to figure out what our argument would be. So another reminder, thinking about cotangent, a reminder, cotangent is equal to our x value over our y value. So right now we want to be thinking about, okay, what could we have as an x value and what could we have as a y value that would give us square root of 3 over 3? And so we're thinking about that, we're thinking about the values that we have on our special right triangles, so 1/2, square root of 2 over 2, and square root of 3 over 2. We're thinking what combination of those could give us square root of 3 over 3. So the answer to that is that if we have 1/2 in the numerator and square root of 3 over 2 in the denominator, then when we multiply by the reciprocal, we get 1 over square root of 3, and then as you remember, we want to rationalize our denominator, which gives us square root of 3 over 3. So those are the x and y values. So then we're thinking, okay, what angles on the unit circle would give us those values? So we're going to end up with pi over 3, and then the other angle that we end up with, let me move myself, is 4 pi over 3, because then we have both a negative 1/2 and a negative square root of 3 over 2, so that becomes positive square root of 3 over 3 when we find our cotangent value. So our angles for this problem are going to be pi over 3 and 4 pi over 3. Okay, moving forward. So we have our two equations, and again, we want to remember that we're finding all solutions to the equation, so we want to add our period to the right side of the equation. And for cotangent and tangent, you'll remember that the period is just pi instead of 2 pi, so we're going to add pi n to the right side of both equations. We also don't want to forget about that pi over 6. This is when that pi over 6 comes into play, so we need to remember that that is going to be on the left side of our equation. So I'm going to start with this equation on the left. And so first thing that we want to do after that is just get this pi over 6 over to the other side of the equation. And we're going to do that by subtracting pi over 6 by both sides. And you can see here that I turned this pi over 3 into a 2 pi over 6 just to make these two expressions easier to combine. So ultimately that's going to give us theta equals pi over 6 plus pi n. Going on to the right side of the equation, again we're going to subtract both sides by pi over 6, and I turn this 4 pi over 3 into 8 pi over 6, so these two would be easy to combine, and that's going to give us a solution, let me move myself, of theta equals 7 pi over 6 plus pi n. Okay, so these two equations are our solutions, but we can actually get our answer to be a little more simple, and I'll show you how. So just thinking about our two equations, let's say that n equals 1, and we're looking at this right side of the equation. So n equals 1 for that, so we're going to have theta equals pi over 6 plus pi times 1, because n is equal to 1. And then to combine these two, I'm going to give this a denominator of 6, so that's going to become pi over 6 plus 6 pi over 6, and we add that together, and that gives us theta equals 7 pi over 6. But hey, that's pretty much the same as this equation, right? So say that n was 0 here, then that would give us 7 pi over 6. So because of this, you can see that this expression here actually takes into account this other expression. When we add pi to pi over 6, that gives us 7 pi over 6. So we don't need to include this in our final answer. So our final answer is just going to be theta equals pi over 6 plus pi n. Okay, those were the two examples that I wanted to walk through. I hope that that was helpful for everyone. Definitely, if you have any comments or questions or feedback, please reach out to me or Mrs. Amy or Mr. Iwoka. Thanks a lot.